I've been asked to find the equation for this exponential function that they've given me a table of and some of the basic attributes about it. Now, to start out with, I need to know a couple of items in order to write my equation, because my equation goes in the form of y equals a times b raised to the x, where the a is my y-intercept and the b is my factor or my multiplier, and I'm raising it to the power of x. So when I look at this table, the first thing I need to identify is my y-intercept. That's where x is 0. So my y-intercept is 0, 3. And then to find my factor, the easiest way to find my factor is to divide my second term by the first. So I'm just going to say 4.2 divided by 3, and that's going to give me my factor of 1.4. So now I've got my y-intercept and my factor. I can go ahead and write my equation. My equation is y equals my intercept times my factor raised to the power of x. Now the other thing that I'm being asked for is my rate. So I need to know what my rate of change is for this, or what my rate of increase or rate of decrease is. So I can see that it's increasing, and the way that I find rate is I do my b, well, the absolute value of my b minus 1. Let's make that look like a 1. Okay, so the absolute value of b minus 1 is my rate. So my b minus 1, my b is 1.4 minus 1 equals 0.4. So my rate is 0.4, or 40%. Now to find my domain is always the same in exponential functions. It's always all real numbers. And then my range, it's either going to be greater than 0 or less than 0. And if I do a quick sketch of this graph, either in my calculator or on paper, I'm going to see that it's going like this. So I know that it is greater than 0. And the reason it's always greater than 0 and not greater than or equal to 0 is it cannot touch the 0, the x-axis. That's our asymptote. So y equals 0 is our asymptote on this. And then I can just see from looking at this sketch I've drawn that it's increasing from the left to the right.